Just a correction here for page 9 of properties of curves. This one here, it should be F double dashed also, just like the second one. Okay, so we're going to look at these two curves, one facing up and one facing down, and we're going to say whether or not which of these options is true. So when it looks like that, it is concave down. When it looks like that, it's concave up. I think of it as like a cup, or whatever. The cup is facing down or up. What about the second derivative? Is the second derivative increasing or decreasing? Well, if you look at the first derivative, which is m, you can see that, it goes from 2 to 1 to 0 to -1 to -2. Is that increasing or decreasing? Well, it's decreasing. It's going from 2 to -2, so it's decreasing. What about for this one? It starts at -2, it goes to -1. We're always going left to right, okay? 0, 1, 2. It's increasing, right? And then so we could say that the second derivative is negative because it's decreasing, and here it's positive because it's increasing. Okay. A point of inflection is a point on a curve at which there is a change of direction. Or like concavity, maybe you could say also. Concavity. Because when I say direction, I mean like, hey, it's like you're driving, turning left, and then now you're turning right. Or changing concavity, it's like, like right there, it's like changing from cup up to cup down. Okay. If the tangent at a point of inflection is gradient 0, then this point is a stationary or horizontal inflection. In a non-horizontal or non-stationary inflection, the tangent line touches the curve at this point. Draw an example of a non-horizontal inflection here. Oh, I just kind of did there, right? That's a non-horizontal inflection. A horizontal inflection would be, like this. Right there. At that point, it's horizontal. One other option is saying gradient 0 is horizontal. That's the word I was searching for, horizontal. Okay. There is a point of inflection at x equals a if f dash dash a is 0, and the sign of f dash dash changes at x equals a. The point of inflection corresponds to a change in curvature. So make sign diagrams for these situations here, and we could just do that by putting pluses and minuses here on these axes. I think it's easier. So like for here, for example, it's concave down for the whole time. So this would just be all negative. So it would be negative here, and it would be negative here. What about for this one? This is concave up all the time. So it's positive here and positive here. Okay, if we were to label it here, we would say negative, negative, and positive, positive, right? Okay. What about the stationary inflection points? So let's draw one for here. So here it's concave up, here it's concave down, so it would look kind of like that. For this one, it's the opposite. It's concave down and concave up. And here, it's concave down and concave up. And here, it's concave up and concave down. Okay, so those are the sign diagrams for these 6 situations. Make sense? Not too hard. That was a quick page.